Our next dimensional analysis example has two different units that need to be changed at the same time. The first thing we need to do in these more wordy questions is figure out what numbers are actually important. So let's read. The average speed of a nitrogen molecule in air at 25 degrees Celsius is 515 meters per second. Convert this speed to miles per hour. Okay, so when I see this, I see that my main goal in this whole thing is actually to convert the speed. That means that I can pretty much ignore this temperature information. Not helpful. All right, so then that means I only need to focus in on the 515 meters per second. So I'll set up my dimensional analysis. I know that I'm starting with units of meters and seconds. I'm going to put them on two different sides, the top and the bottom of my bar. I'm also going to focus on what units we're looking for at the end. It looks like we're trying to change to miles per hour. I'm going to write that down. Miles per hour. That's what we're looking for at the very end. That means I need to find some way to change the meters into miles and seconds into hours so our American friends can figure out how fast we're going. Okay, that means I'm going to have to Google some stuff. I have no idea how many meters are in 1 mile. Okay, now that I've done that, I can write down that I have my starting number, 515 meters per second, and then I found on Google that there's 1,609.344 meters in 1 mile. And that takes care of my miles issue. So I'm going to go ahead and cross out my meters so that I keep it really clear in my mind that I've already taken care of changing things into miles. Okay, now to get rid of my seconds unit. We did seconds and hours in our last unit. All we have to do is go through our middle step friend, minutes. We know that there are 60 seconds in 1 minute and that there are 60 minutes in 1 hour. This makes it so that my seconds cancel out and that new middle step problem I made for myself, the minutes, those also cancel out, so I end up with units of hours. The beautiful thing about dimensional analysis is that we can use the bars to figure out what units are left over, mile and hours, and those set us up to have the correct units that we are looking for. Okay, so now how do we handle the math so that we can get the right answer? In my calculator, I would punch in 515 times 60 times 60, and then to be safe, I'll hit the equals button. Next, I'll click divide. 1,609.344, ridiculously specific. And since I have all ones on the rest of it, I'm going to leave it there and click equals. My answer is reported with sig figs and everything. Well, let's do the sig figs together. Let's see, 1,152.02219. Yeah, I obviously cannot report that entire answer. Since I started out with 3 significant figures, that's how many I need to end with. So I'm going to look at these first 3 digits, 115, and I see that I have a 2 on the end, so I don't need to write that. I can write this answer as 1,150. Or I can equivalently write this as 1.15 times 10 to the third miles per hour. Please note that for most of these problems, your answers aren't correct if you don't have your units, so make sure that you always write your units. And that's all you need to know to handle dimensional analysis problems where you have a unit that is actually 2 units, like meters per second or miles per hour.